Hello PHP developers. Today we're going to take a look at interfaces and what they are, why we should use them, why we should care about them, and all of that stuff. I was actually going to talk about design patterns today. I was going to talk about factories and adapter patterns and stuff like that, because with the client that I'm dealing with at the moment, I'm refactoring a bunch of code that I've written that could be best used in these design patterns. But I haven't actually talked about interfaces today. We kind of need to talk about interfaces before we even jump on the design pattern route. I've got a cup of tea here. I don't know if you can see. It's my new PHP Run PHP mug, because my throat is unfortunately a little sore still. This British summer is well, let's just say it's quite wet. So the cold is coming. Let's just talk about interfaces then. Let's dive in and write some code. So an interface is a way of doing some sort of encapsulation, if you will, some sort of segregation between the behaviors of classes. So it's a way of defining a set of rules of how a class or a collection of classes should behave. And when you implement those, you're saying that class, your base class, or your concrete class should implement those methods that interface defines. Okay, why is this a good thing? Because it allows you to decouple your classes. I'm going to get into that a little bit more as we go on. This talk is going to be a little lengthy because there's a couple of examples that I want to show, so please bear with me. I'll try and be as thorough as I can. Let's talk about a problem first, and then I'll talk about the interfaces as a solution to that problem. So let's say, for example, we have a bunch of classes that all have define how a shape can be painted. Maybe you've got an artist that is painting a bunch of shapes. So for example, we could have class, let's do circle, for instance. And that class has a bunch of public methods that is, so for example, draw, like this. And of course, this needs to be, sorry, I'm not doing an interface right now. I'm doing a function. Like that. Okay, so that's cool. Okay, so we also have another one. Let's copy that, and I'm going to call this just color, and I am going to spell it in the English way. Let's save that. And maybe we have a bunch of other shapes. So we have a circle here. We could have a square, like so. Square. Spell obviously in the right way, like so. And for good measure, let's just do a line, like so. Okay, so these obviously have a common set of things: draw, color. Now, obviously, when you're drawing a circle, you're drawing it slightly differently to a square, and obviously just a single line. And also, when you're coloring in as well, you might be doing different things with that too. Now, let's define the painter class. Now, the painter is going to be the thing that actually does the drawing. So we're going to do class painter, like so. And this class is simply going to have a function public function, and this is going to have add shape, like this. Okay, and this is just going to take a shape, and it's just going to do return shape, and we're just going to do draw, like that. Okay, so and obviously I need to put in the shape, like so. Okay, so that's all set up. Now let's actually start creating some variables off of the back of this. Let's do a variable. Let's call this artist. And this is going to be a new instance of painter. So this is instantiating the painter class. And we're also going to have above that, we're going to have another class, and we're just going to call this shape. And this is just going to be a new, let's do circle for now. And then we can do artist, and we're using the public method here. which is add shape, and we're passing in the shape. Make sense? All good? We have 3 classes, which are shapes. They all have the same methods, color, draw, and so forth. And we have a painter class, which adds the shape to the painting, I guess. So we have add shape, and we pass in the shape like so. Now, what we can do is obviously supply the instance type to the add shape. But if we did that, then we would be coupling the shape class to the painter class. So, for example, we could do circle like this, because we don't know that we have the draw function here. Pretend that these are all in separate files, and maybe these have been written by completely different people, okay, on your team. So what we can do is supply the circle like this, but this means that we can't supply a square like that, because it's not a circle. Yet it does all the same things as the circle does. So we can't do that. That is coupling the classes together. That is making this painter class be very aware of the classes that are being injected into this thing, which isn't good. It's not good. What we need to do is do something like interface segregation, where we are planning we're designing our classes in a way that doesn't force coupling, doesn't say that you need to have a circle in order to add a shape to for the painter. By doing this, we are blocking ourselves, if you will. We're saying, well, we can't add a square, we can't add a line to this, because we're only saying that we can only put in a circle. So this is wrong. This is not a good thing to do. The way to get around that, of course, let's just remove that, is to have an interface. So an interface, again, like I said, it's a way of defining a set of rules. So let's do an interface, and we're just going to do shape interface like so. Okay, and I'm going to have just a public function, of draw, and also a public function of color. Okay, which means now that these classes, these shape classes, can now implement the shape interface. So we type in implements, because that's the key word, and we type in shape interface like so. So let's just copy all of these things, put them all down in here. All good, all good, all good, all good. So now we can provide the interface into the add shape method. So for example, here we do shape interface, and we know that the shape interface will always have the draw and the color methods. So here we can do draw, and here we can do color as well. Okay, so what we've done is we've decoupled the particular concrete class from this method. So that's kind of a very low-level way of looking at what an interface does. It's a way of bridging that gap. Maybe one day we have another function in here. Maybe we have public function redraw, okay, like this. And notice that here all of these have gone red, and that is because we are not, can you see if I hover over, class must be declared abstract or implement a method redraw. That's because we've defined a public function redraw in here, but we haven't defined it in there. So it's a way of enforcing a rule, a set of rules. So to fix this, you would do public function redraw like that, and I'm just going to copy this all the way to the others because I'm lazy, like that. Okay, so now that will work because we have implemented redraw. I'm going to move on to something a little bit more advanced with interfaces, but what I'll do is I'll commit this to the GitHub repo. So let's just save that. So let's start advancing this a little bit further and talk about payment gateways. So something that a lot of you are probably familiar with is payment gateways. You've got loads of them: PayPal, WellPay, SagePay, all of that stuff. How can we create a system that allows us to process payments in a plug-in kind of way where you're plugging in different types of payment gateways. Maybe your client comes to you and says, you know what, the PayPal's been great, but we want to try something else as well as PayPal. Maybe it's Google Pay and so forth. How is there a way that we can create a bunch of rule sets, interfaces, if you will, to make sure that all of the payment gateways conform to what we need to do? And maybe some of these payment gateways have different ways of processing payments. Maybe they do fraud checks, 3D secure, and all that stuff. So let's start looking at that. What I'm going to do is just do another class here. And we're going to do, instead of, I don't want to use any names of stuff, so let's just do pay fee. I think you can probably guess what these represent, but hey ho, pay fee, and that has a method, a public function of pay, right? Like so. And let's just copy that and create world fee, and let's do mint fee. Okay, so pretend these are different types of payment gateways. So pay fee, world fee, and mint fee. And they all have a public function of pay. Okay, so what I'm going to do, like with the shape example, I'm going to have another class that handles these things. So in this case, I'm going to do class is payment gateway, gateway, like that. And what I'm going to have is a public function like so, where we call this take payment, yeah? And we're going to put in a payment type like so. Now, this is probably not the best way of creating payment gateways. I'm just, this is just for an example, right? I wouldn't call these things like this. But it's set up in a similar way to the shape function. And so what we can do here is just do payment type and then just do pay like that. Okay, so let's instantiate these classes. So payment type is equal to, we're going to do new pay fee like that. And we're also going to have a gateway, which is new payment gateway. And gateway, we're going to take the payment, passing in the payment type. Fine. Okay, that is all looking fairly familiar to the shape example. And what we can do is create an interface, and call this standard payment interface. Yeah. And the standard payment interface has a public function of pay like this. And what we can do is now implement that. So implements standard payment interface. That's all well and good. Let's just copy that through. And oops, no, not on you. And that now takes the standard payment interface. Yeah, makes sense. So we've created these classes much like we've done in the shape example, and these implement a standard payment interface. Now, one of these things or some of these things could behave slightly differently. Notice that we haven't actually defined the behaviors yet. This is something that we're going to work on. Maybe one of them does a checks for fraud, right? So, for example, let's do mint fee. Just picking one out from random. Let's do public function. Let's do a fraud check, yeah? Like so. What we are assuming is that these payment gateways, these payment types have this fraud check available. So if we did payment type fraud check, right, like that, and let's just put this at the top, make it a little bit more sensible. So it does a fraud check and then it does a pay. Now, the problem here is that Mint Pay has the fraud check, but Weld Fee and Pay Fee do not have a fraud check in them. So when we're passing in Pay Fee into this as this argument into take payment, we can't. This is going to fail because we can't do a fraud check passing in Pay Fee because it doesn't have it. Now it could be that this Pay Fee just doesn't do fraud checks. Okay. Now you could be thinking that a cheap and dirty way to fix this is to have public function fraud check in here, right? But the problem with that, let's just type that out. But the problem with this is that you need to include fraud check in each of these classes. But Pay Fee just doesn't have a fraud check. So you're implementing a method that just won't be used, and you really shouldn't have any methods that just don't have anything in them, right? Because that's pointless. You're not designing your code very well. There's an architectural problem with this. So Weld Fee might have a fraud check, but Pay Fee doesn't. So there's no point. So what you could do is have another interface. So you do an interface, and we call this. Let's make it a little bit better. Transaction check interface, right? Because then it might be checking for other things. So let's have public function fraud check in here. All good. And now what you can do is you can implement the standard payment interface, but also the transaction check interface too, because that has fraud check. Now you're not implementing fraud check in the standard interface. You're not having that in the standard interface. So Pay Fee and Weld Fee don't need to shouldn't have the knowledge of doing a fraud check because they can't. But still, we have this problem here. We want to pass in Mint Fee into here, and we want to do a fraud check. So how do we do a fraud check from take payment? Because standard payment interface just doesn't have that method. And if we did transaction interface instead of the standard payment interface, this would work. But of course, it won't work if we passed in Pay Fee, and you're no better off just how it was before, where you're coupling the classes to this processor. So what you could do is create another interface that handles it from a slightly more of an abstract level. Let's just Control Z that back to standard. So let's scroll up a little bit more. So what I want to do is create another interface that will handle the different use cases, so pay or fraud check. So in this case, we do an interface, and we're going to do just payment process. Process interface like that, okay? And we're going to have a public function, and we're going to have just the word process, the function process like that. Okay, so Pay Fee is going to implement standard payment interface as well as payment processor interface, and also that is going to implement that too, and also this is going to implement that too. It doesn't matter the order. But what we need to do obviously is actually put in the process function. So public function process. Let's just remove all of that for now, just to make some room. Copy that, bung that into here, bung that into there, and everyone's a winner. So what we've done is we've created a third interface called process, or payment process, with the function of process. What I'm going to do is change standard payment interface to process interface, so we can pass that in. So they all have payment process, that's fine. But here, what I'm going to do is in the actual process method, I'm going to do this fraud check as well as this pay, right? And in this one here, in the Weld Fee, it doesn't have fraud checks, so I'm going to do this, this pay, Let's just do that, as well as in here. So this pay, like so. Now what we've done is we've said, well, look, there's a payment process which will decide what to do. Okay, so this is the decision maker. This is the actual thing. This is the thing that will cause the payment, obviously, but it will decide how we do that. So it will decide whether we need to do a fraud check first, or and so forth. And by passing in here, we don't need to do any of this stuff anymore. We can just do process. Yeah. So payment type process will fire off process, which will fire off for the pay fee, for example, we'll fire this one off, which just does this pay. Same with weld fee, that will do process, which is just this pay. But with mint fee, it will do process and it will do a fraud check. Now let's make this a little bit more advanced. Perhaps there's not only does it do a fraud check. Let's just change that to be fraud. Fraud check, like that. Let's just copy that, put that into here. So like so, fraud check interface. Okay. Maybe it does another one. So maybe it does a 3D secure check, right? So here we could do 3D check. And maybe this class here, the pay fee, does, let's just bung it here and here for argument's sake. Maybe that does a 3D check. So let's do a public function, 3D check, like so. Let's just close that to make some room. So we have got two classes doing some form of checking. So mint fee is doing a fraud check, and pay fee here is doing a 3D check. Okay, so in process we do this 3D check. Whoopsie. So we haven't actually altered anything here. Okay, can you see that I've altered the behavior of the pay fee class, but I haven't altered how this payment type gets handled. And in doing that, you are segregating the responsibility. You're saying, well, this pay fee up here has a single responsibility to do process, and that's going to do, because it implements the 3D secure. It's doing a 3D check and a payment. But you haven't altered your concrete class at all here. You haven't altered how this gets affected. So you can start creating very small, isolated, segregated classes in this manner. Now, I do appreciate this is far advanced compared to what we usually talk about on this channel when I'm talking about HTML forms and all of that stuff. So what I'm going to do is just push this up to the GitHub repo, but I hope it does help out. In the future, of course, I want to talk about more advanced stuff, especially with design patterns, solid principles, and all of this stuff, this is slowly leading into that. Just remember, an interface is a way of defining a series of rules for your classes, and it allows you to break the chains, if you will, between what your class's behavior should be. Okay, if we didn't have an interface here, we would be very stuck with using multiple payment types. Same with the shape example, we would be very stuck with that one particular shape if we only required it here. So this is a way of breaking that up and saying, well, this interface can decide how this class should act. Okay, so we just have a very abstract call here called process, but process can be interpreted differently in these classes, right? So for example, here we do a fraud check and then a payment. Here we just do a payment. Here we do a 3D check and a payment. So it's a way of abstracting out, if you will, those kind of methods, and it's giving the actual classes themselves, the pay fee, weld fee, and mint fee, the responsibility of what they should do. You're not passing the responsibility onto here. You're not saying, okay, we must do a fraud check. We must do a pay. So we're not actually having a bunch of if statements in here saying if instance is mint fee, do a fraud check. If instance is world pay, do nothing. If instance is a pay fee, do a 3D check. Okay, and then do a pay. That becomes very messy. You're coupling your classes together, which is a bad code smell for object orientation. Hopefully you found this useful. Hopefully you found this helpful. If you have, do share it around, do subscribe to pick up the next tutorials, because I do a tutorial like this every Tuesday, as well as a web chat every Friday. And recently I've been talking about freelance and interview processes and what you should do and what you shouldn't do in a web development interview and so forth. So do check those out. To subscribe if you haven't done so already. But anyway, I'm going to grab a little bit more tea. Thanks again for watching, and I shall see you again in the next episode. Cheers.